Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Today I am going to discuss Assalamu alaikum wa rahmatullahi wa barakatuh. Today I am going to discuss about shells, subshells and electronic configuration. Shells are the path for the movement of electrons around the nucleus. An electronic configuration, it is the arrangement of electrons in different subshells. Subshells are the further classification of shell. K shell has S subshell. L shell has S and P subshell. M shell has SPD subshells. M shell has SPDF subshells. Okay. The innermost in this picture diagram, the innermost circle is K shell and it has maximum capacity of 2 electrons. Okay, this you have studied doublet rule. This K shell follow doublet rule, 2 electrons, which is present in helium, and the other shells are inner shells. The last one, the outermost, is outer shell, and blue are the electrons. Quick way to calculate number of electrons in main energy levels. Well, these shells are also energy levels, and this was calculated. This is calculated by formula 2n square. N is the energy level. If K shell, then N is 1. How can you calculate? If N is 1, that is K shell, then 2 1 square equals to 2 1, and 2 1s are 2, so 2 electrons. These 2 electrons in K shell. If N is 2, then 2 2 square, and then it becomes 8 electron, then 18, then 32. So these are the maximum capacities of electron in different shells like K2, L8, M18 and N32. Okay, this is more detail, more explanation of 2n square. The center is nucleus. The first circle after the nucleus is K shell, N is 1, and L is 2, N is 2, M shell, N equals to 3, and N shell, N equals to 4. How can we calculate? The maximum number of electrons present in a particular shell is calculated by the formula 2n square, where n represents the shell number. And this 2n square formula was given by Bohr's. I think so. Bohr's atomic theory left. Inshallah, I will explain. Okay. For instance, K shell is the first shell, and it can hold 2 1 square, that is 2 electrons in K shell, and L shell can accommodate 8 electrons in this shell. This one. How can we write electronic configuration? Electronic configuration is the arrangement of electrons in different subshells, S, P, D, F. How can we write like this? 1, 2, 3, 4, 5, 6, 7. These numbers are the period. There are 7 periods in periodic table, 7 shells, so 7 number. N1, these are the n values, n equals to 1. If n is 1, 2 electrons can be accommodated. So for that, only subshell S is required. That's why I wrote 1s2. Then 2s2, 2p6, this is L shell. L shell has maximum capacity 8 electrons. So 2 plus 6, 8. Then M, 3s2, 3p6, 3d10. Total will be 18. Fourth, N for N, 4s2, 4p6, 4d10, 4f14 become 32, and so on. Okay, then put arrows. Put arrows from top to arrowhead downward, and then write the order like this. Start from 1s2, then go up, then 2s2, then go up 2p6, 3s2, then go up 3p6, 4s2, then go up 3d10, 4p6, 5s2, then 4d10, 5p6, 6s2, and so on. Okay. So for writing electronic configuration, always follow this order. Okay, I will show you. For example, you are writing electronic configuration of hydrogen. Hydrogen is having one atomic number, so 1s1. Helium 2, so 1s2. Lithium for 3 electrons. So how can you fill? You cannot write 1s3 because S has maximum capacity 2. So move that electron to another subshell, that is 1s2, 2s1. Beryllium 4, 1s2, 2s2. Boron 5, we cannot write 1s2, 2s3. No, that one electron moved toward third subshell, third order, third writings, 1s2, 2s2, 2p1. We cannot write 1s2, 2p, 2s3. Carbon, 6 atomic number, 6 electrons, so 1s2, 2s2, 2p2. For nitrogen, 7, 1s2, 2s2, 2p3. Okay, we cannot write 1s2, 2s, 2s5, no. 3 electrons move toward p3, and p has maximum capacity 6, so it can take 6 electrons, but not more than 6. Less than 6 is allowed in p suborbital. Less than 2 is allowed in s subshells, but not more than 2 for subshell S, not more than 6 for p subshell. Okay, this is oxygen, 8 atomic number, 1s2, 2s2, 2p4. Fluorine, 1s2, 2s2, 2p5. Then neon is filled, completely filled, because this is noble gas. This neon, 1s2, 2s2, 2p6. This is placed in brake lights. You can see red light when during when cars are stopped in signal, on signal, then that red light is neon. Okay, 11 sodium, 1s2, 2s2, 2p6, 3s1. We cannot write 1s2, 2s2, 2p7 because p has maximum capacity 6, so it should move to other. Then magnesium, 1s2, 2s2, 2p6, 3s2. For aluminium, 1s2, 2s2, 2p6, 3s2, 3p1. Add total Check the total. 2 plus 2 plus 6 plus 2 plus 1. It is 13. 14. Silicon. For silicon we write 1s2, 2s2, 2p6, 3s2, 3p2. Phosphorus 15. 1s2, 2s2, 2p6, 3s2, 3p3. Okay. Allah Hafiz.